Hey guys, how's it going? Welcome back to my channel. Today we are going to be continuing the LeetCode 75 study plan series, and we are going to be doing another one of the sliding window category problems. This problem is called maximum number of vowels in a substring of given length. So let's get to it. So for the instructions, pretty straightforward. Given a string s and an integer k, return the maximum number of vowel letters in any substring of s with length k. Vowel letters in English are A, E, I, O, and U. And then it shows a few examples here. So the substring I contains 3 vowel letters, and that's the longest continuous substring of vowels. So we're going to return 3. Um, let's go ahead and get started. All right, so the first thing that we want to do is we want to create a set of all the vowels. And then basically what we're going to do is we're going to create 2 loops in the solution. And then the first loop is basically going to check the input string and see if it contains any of those vowels in the size of our k input parameter. So I'll show you what that looks like. So first, for those of you who haven't created a set before in Java, it's pretty straightforward. It's just set, and then it's going to be characters. So set of characters, and then we can call this, let's just call it vowels. And then we'll set this equal to set of, and then we want to do a, or no, we're going to do the single quotes. Okay, A, E, I, O, and U. All right. Now after we create our set, we want to initialize a count variable, which is basically going to count the number of vowels in the first k length substring. So we'll just set that to 0. Pretty straightforward. Okay, and then now we're going to create our first loop. So we're going to set I to 0, and then we're going to set I is less than k, so it goes to the size of the k input integer, and then we'll just iterate up. Okay, so then now basically what we're going to do is we're going to use a ternary operator to see if the set contains a vowel. And the reason that I chose the set is because there's built-in methods in Java to make our job easier. So we're going to do plus equals, and then vowels dot contains, which is the built-in method I was talking about, s, which is our input string, char at I, and then question mark for our ternary operator, 1, 0. So let me explain this statement for those of you who are unfamiliar with what this is doing. So vowels is our set, right? We're using the built-in method contains to check inside of our set for each iteration inside of the loop. So we're checking at index I of the input string s. So basically, if the input string s contains a vowel, then we're going to increase count by 1, which is on the left side of the ternary operator. If there's no vowel, if it doesn't match A, E, I, O, or U, then we're not going to increase it. We're going to add 0. So that's like the first part of our sliding window. Now we're going to have to see if we adjust the window, if there's going to be more vowels in that continuous substring of size k. So we're going to basically we're going to have to keep count of or keep a record of our count, right, to compare it to. So what we're going to need to do is set int answer equal to count, and we're going to be using answer to compare to count when we're sliding the window, to use the terminology. Okay, so now we're going to create our second loop, int I, and then we're going to be starting at k, because that's where we left off of at the first loop. And then we'll go to the rest of the input string s. So s.length, we're going to have to add the parentheses. And then we're going to iterate up. Okay. So now we're going to set basically two more ternary operators to either subtract and add as we progress through the sliding window. So we're going to be adjusting the count, right? So count is equal to, or plus equals, vowels dot contains s char at I. All right, 1, 0, just like the statement above. And then now we're going to do the same thing, but for the index that's getting left out of the sliding window as we're progressing through, right? Because the size of the window k stays the same, so we have to get rid of the variable on the left side, if that makes sense. So we'll do minus equals vowels dot contains s dot char at, and then we'll do I minus k because the window's size k, and then the same thing as our previous ternary operators, 1 if true, 0 if not. And then now what we need to do is compare our answer with our count in each iteration of changing the size of the sliding window. Alright, so answer equals, and then in order to compare, what I've done in my previous videos, and I'll show you now, is math max. So it's part of the math library that's built in. We use the math method, and then we compare answer and count. So answer is going to be the largest, basically the largest count, the largest amount of vowels in that sliding window. So that's what that statement does. And then all we need to do now is return the answer. So let's go ahead and run that, make sure it passes the basic test cases. Alright, so as you can see, it passes the first 3. So let's go ahead and submit it, make sure we pass the rest of the test cases, and then there we go, we passed them. We have a runtime of 49 milliseconds, so not the fastest. However, if we're going to be analyzing the time and space complexity, this solution is still big O of n, which is the typical time complexity for sliding window technique. So this is the standard amount of time complexity because we're just going through the for loops and we're not nesting them, so it's not exponential time complexity. They're separate from each other, so it's just going to remain big O of n. And then for the space complexity, it's just going to be constant because we have a set right here, but it's a fixed size, so that doesn't affect the space complexity. There's nothing that scales with the input variable in terms of data structures, so we don't have anything there. So we can call our space complexity big O of 1. And so that is it for today's video. If you guys learned more about the sliding window technique, please go ahead and leave a like and subscribe for more related content. I hope that this video helps you. My whole goal with this series is that I was going to touch on specific categories of the kind of essential parts of coding interviews for the technical whiteboard problems, so you can kind of master each individual area. So I hope that you watch my last video on the sliding window technique, and in addition to this video and in the other videos to come, that you're gonna be able to master this particular category of coding. So go ahead, go on LeetCode and try it for yourself and improve your skills. And yeah, go ahead and subscribe for more related content. And then if you have any suggestions, please feel free to leave those in the comment section below. And we will see you in the next video.